So we might get started. Thanks everyone for joining in the afternoon. The last day of the conference is always difficult to get a full room, but we're delighted to have you here. So you've joined a session on sharing and validating best practices for energy efficient manufacturing, which is a collaborative workshop between two Horizon 2020 projects, so the DENIM and the E2COMATION project. My own name is McGibney. I'm from MTU and I'm one of the coordinators on the DENIM project. And on stage here we have Andrea. Do you want to introduce yourself?
Hi all, my name is Andrea Ballarino from Italian National Research Council and I'm the coordinator of E2COMATION. Nice to have you here.
And Susan, if you want to introduce yourself.
Hi, my name is Susan Ray and I'm part of the coordination team for the DENIM project at MTU. Thanks.
So today you'll get some insights into what we've done as part of those projects, but we've also kind of come together to wrap up the kind of outcomes of these projects that have run for the last 4 years now, and try to devise best practices out of that for energy efficient manufacturing. So hopefully it will be a bit of a kind of interactive session. So we'll just introduce the collaborative approach that we took, the best practices that we've devised between the two projects. We'll give a little bit more insight then into the technical aspects of each of the projects, and then we might just ask for some feedback and have a little bit of a discussion around the best practices that you'll see today, and maybe how we could disseminate them further going forward. So with regards to the activities that you will see today, it's a part of a kind of strategic collaboration across European projects. So we have a number of EU projects that come together initially as part of the Engine initiative, which is run and managed by SUPSI. That brings European projects together to share results and have a forum to discuss commonalities between projects. As part of these activities, we applied for a Horizon booster service, which supports bringing projects together and sharing and supporting them in disseminating their results. So we have 6 projects altogether as part of this cluster, which is called Eco Energy, and they gave us a nice logo as well on the top left corner to use. And across these projects, we're all looking at energy optimization, energy efficiency, one way or another, lots of manufacturing, but also around digital technologies, data management, and then approaches for assessment of sustainability, digitalization and interoperability across these projects. So as part of the outcomes of each of these projects, we have a set of solutions or a set of outcomes that are kind of common, I suppose, and that can be shared in different contexts. So this includes software platforms for sustainable manufacturing management and optimization. As part of DENIM, we've developed the digital intelligence platform, which you'll hear a little bit about shortly. We also had quite a focus on simulation and digital twins, and using that to support energy and environmental performance analysis, assessment and improvement, and also around building optimization, energy systems optimization and process optimization. And we also included some aspects of cyber-physical systems for industrial data collection across different sectors. So just a little bit about the individual projects and the solutions that are developed. So DENIM is all about collaborative approach to energy efficient manufacturing, and we developed an integrated tool chain that allows us to provision or deploy advanced digital services. So that can be from edge analytics, IoT devices, up to developing digital twins, energy modeling and automation. And what the platform delivers is an approach to continuously monitor and manage energy impact in the manufacturing context, and obviously be able to deploy new strategies for energy control and optimization across different levels of granularity, whether it be right at the production floor or up to at the site level. So there's a number of building blocks associated with this. So you can see on the right of the figure there. So we developed a digital thread, which allowed us to collect the data, decision support tools to help with production planning, these kind of elements, and then energy-centric digital twins. So a lot about modeling and I suppose efficient ways to develop these models for dynamic energy prediction. And then on the left-hand side, we integrated these across different systems and tried to address interoperability in the manufacturing context. Because we're reliant a lot on digital technologies, we've had a focus on assessing the workforce in terms of upskilling and training, and we created a community of practice around that. And then performance assessment is very important, so defining the right key performance indicators, using methods like life cycle analysis and cost analysis was really important. And then in the middle, what we want to base the technologies on is standards, and to kind of inform standards and apply standards. We're promoting energy efficiency. Data protection is very important to all the sectors that we had involved in the project, and we want to promote best practices across all the different sectors that are involved in this project. So a little bit about the pilot cases. So we had 4 pilots. Each were quite diverse in their size, their scale, their digital maturity, I would say. So they all offered different challenges for us as a project to deliver digital solutions into them. So we had we have a pilot in Ireland which is focused on medical device manufacturing. We had a pilot in Spain which is very energy intensive steel making process and forging process, where we're focused on deploying the solutions. We had an SME in Italy that develops composite parts, so very bespoke solutions and products that they develop, so it was quite challenging from that perspective. And then Garanje, who develop machining and tools for the automotive industry, another large company in Slovenia. So that's a little bit about DENIM. So we might hear a little bit about the E2COMATION, Andrea.
Thank you, Alan. As Alan said, we are a sister project, so you will hear and listen about common elements from the 2 projects. If we want to dig a bit more into E2COMATION, when it comes to energy optimization, the keyword is being proactive. What does it mean? It means that if we want not only to assess, but also to monitor, predict, and steer production, we have to do it while it's happening, or slightly before it is happening. So this means that in order to be proactive, we have to elaborate at various levels, starting from the shop floor, starting from data gathering, being reactive in raising insights, working on string computing, and being active in analytics, in order to empower different layers, different tools that are part of the platform that E2COMATION has developed. The keyword in E2COMATION is being energy aware, so considering energy not as a consequence of decision in production, but as an ingredient of decision. So putting energy and its consumption as a variable to be manipulated in control, in planning, in order to be energy sensitive, be energy aware, and be energy saving. We are talking in general about digital energy saving. So both projects worked on digital approaches to energy saving. We didn't develop new technologies, but we leverage an existing technology to squeeze out the best out of them. So this applies to E2COMATION, which developed in the end also a decision support platform that integrates several tools on energy, on sustainability at the various levels of the process, elaborating from analytics to digital twin till the tool level for optimization. Also in the E2COMATION case, we focus on 2 different value chains. The first of which are the woodworking one. We had 2 pilots in the same value chain. The first one is the Kias pilot in Istanbul. It's a company which performs MDF fiberboard production, so it's a kind of continuous process. It's a more process industry, so we have thermal electric energy through process optimization here. Then it comes downstream, we come to a more discrete manufacturing site, which is Royo. It's a furniture manufacturing, where here energy aware production scheduling and optimization of energy cogeneration are the keys to leverage. And the Gemini approach was in the food and beverage sector, having, first of all, Mahou San Miguel, which is one of the biggest brewery and beer producers in Europe. And here the problem is handling high-speed production process evaluation and performing energy optimization on a process which is very fast. Just to give you a taste of this, we are talking about 50,000 cans per hour, flowing through the line, so high-speed things. And we covered also the part related to the retail in order to be able to save energy also in a slowly flowing process. So different flavors, and the idea with Alan and Susan was to combine the commonalities of these use cases and of our approaches in order to offer you our common denominator, what we can hope to deliver to you and to transfer to industry. Thank you.
Yeah, so to be a little bit more specific then around the best practices. So the projects were, these two projects were funded under the same Horizon call, Factories of the Future call around energy efficiency. So we had a set of shared requirements that we needed to do. But obviously there were two projects that were run independently. So we were both developing new technologies. We were validating the solutions in different sectors and different use cases. And we had different approaches in terms of maximizing the impact and the pathway of impact for each of these projects. But the common outcome that we have to provide as part of these projects is definition of best practices that we can give to industry. They can take on board the lessons learned in these projects and apply them in their own context. So from a denim perspective, we took a kind of a technology-driven approach to define these practices, best practices. So we were looking at the specific needs from a digital technologies perspective, and we created best practices and principles around that. And from E2COMATION, the approach taken was more focused on addressing the needs of industry through their use cases. And as a result, a set of best practices emerged. But obviously, when we came together and we talked about the projects and what we were doing, it became clear that there was quite an overlap between both, because both used digital technologies and both were trying to validate in particular use case scenarios that were kind of aligned in terms of the challenges that we were addressing. So out of that, we've tried to build these shared best practices together. And what we want to do today is share them with you and maybe get some feedback on whether they make sense, whether we've missed anything, and maybe your thoughts on how we might maximize the dissemination of that or the application of these in other sectors, domains, and areas that might be of interest for you. So in terms of the approach or methodology around defining these best practices, so both projects follow this direction. And the first step really is understanding the context. So what do we need best practices for? So this involved really close engagement with our industry partners, our external stakeholders that we created, and across the projects as well, the other projects that were funded in this area too. So we collected a bit of information about that, some work requirements, and gave us a kind of specification of the direction for the projects. We also looked at what was the current state of the art with regards to best practices around energy efficiency, around digitalization, around cost savings, modeling, and optimization approaches. And that helped us then inform stakeholders in terms of what's available and what's possible, and get feedback in terms of what their real needs are. Then we looked at, okay, if we have a best practice, what do we want to get out of it? So what are the success criteria of having these best practices? And if they're applied in reality, what's the value that it can generate for those that use them? And then we kind of analysed these, categorised them together, and selected the ones that we felt was most appropriate out of the two projects. And we're at the stage now whereas we've applied these in the context of use cases, so we've validated them in the context of our pilots, and we'll give a little bit more detail of how we did that later. And we're kind of refining them and trying to understand, okay, how do we share this to the broader community and generate value from that. So that's where we are in terms of the best practices repository that we're developing. In terms of the criteria that we use to qualify an aspect as a best practice, we looked at 5 elements. So replicability was really important, and I think that was really important in both projects in terms of being able to demonstrate the technology across different sites as well. So it was important for us, whatever best practice could be adapted and applied in different sectors. And then the efficiency was the next one, where we looked at being able to demonstrate performance enhancements over existing approaches and conventional processes that might be applied now. And then around innovation, so whether we can contribute or can provide novel organizational or business models and also looking at the integration of cutting-edge technologies and supporting industry and enabling them to do that as part of their digitalization journey. Market compliance was another element that we used as a criteria for selecting the best practice. So we need to make sure that it was implementable. So we do that through validating our use cases, and that it fits into the existing economic and industrial framework to make sure that it can be taken on board and actually applied. And the last one then is relevance. So how do we encourage, I suppose, and compel people to adopt these best practices and ensure that environmental sustainability and economic benefits can be achieved by applying these in real world terms. So with regards to the understanding the context, so the general scope for the factories of the future, there were key drivers that were common across both projects. So data plays a big role in understanding the performance and optimizing energy efficiency. So that was a key element that we looked at. Then accurate monitoring, verification, decision support, as you heard in the elements of the solutions that we provided, was really important. And then promoting the use of standards and maybe contributing to standards, and also workforce development was really important for driving our best practice selection. So what I'll present now is a subset of the best practices that we have. So we'll provide it in a way that we'll say why it's important, or we feel it's important to have these best practices, what you can do with the best practice, and then a little bit of a reference to the outcomes of the project that contribute to this specific best practice. So the first one and the most important step really is being able to set the strategic objectives for digitalization and energy efficiency. So really, if you don't know where the problem is, it's very hard to adapt solutions for it. So we need to pinpoint where the inefficiencies are, understand where we are in terms of digital technology adoption, and identify the areas where we can enhance and improve the existing operations. Through the tools that we provided, this allows organizations then to prioritize projects, investments, initiatives around digitalization, streamline the process, and ultimately embedding sustainability goals in an effective manner into existing approaches for their organization. So to support that, we developed a set of tools and technologies. So we basically created a mechanism to capture the organizational strategy and the existing status quo with regards to digitalization. And we did a gap analysis of the ICT infrastructure, the digital tools that they use and miss and could leverage. And then we have a kind of a formal or systematic approach to assess the digital maturity of an organization. And we can leverage that then to do a bit of road mapping in terms of the priorities that should be focused on to enhance the energy efficiency element of it. So that's our first best practice. And the next stage would be around optimal strategies for reliable data management. So as I mentioned, data really is the driving force behind the energy efficient decision making. So what we wanted to do is we need is strategies for cooperation across the different stakeholders in the value chain to be able to share data, knowledge, awareness, and we want to kind of facilitate the creation of these data-driven workflows to address energy efficiency. So what we can do as projects is we can support easing the integration of these digital technologies and provide them as an enabler then to improve interoperability, connectivity between the technologies that are deployed across the manufacturing processes. So there's often data silos that need to be broken down, and these technologies can offer opportunities to do that. So the specific outcomes of the projects, so we have a strategy for identifying which data is needed, because we don't want to collect lots of data for the sake of it, because you just end up creating a new silo. So kind of prioritizing what data is required and how we can collect that, whether we need new sensors, whether we need new monitoring capabilities deployed on site. Then develop data connectors and approaches to ensure that the quality of the data that we're collecting is good, and do that on a continuous basis to make sure that we have reliable data feeds for models, tools, and decision support systems. And then monitoring the energy flows across the different elements from the machine right up to process and production planning. So these were the three kind of main capabilities to support this best practice. Yeah.
If I may just add a couple of words on this, I mean, all of the best practices are very important, but let me say reliable data management is a key cornerstone. I mean, in the common perception of industry, one may think of a very well-monitored process or with a high granularity. The point in industry today is that energy monitoring comes, most of the cases, at the level of 1 meter, getting the energy values of a full line or a full plan. So when we talk about data granularity, data availability, collecting data, getting out from existing machines, most of the time with legacy systems, and developing an energy image that can be used in order to optimize them. This is one of the main barriers that we have, I think, struggled with. And in order to elaborate, sometimes retrofitting, sometimes complementing solutions to be able to get out the data without asking industry to completely revamp the plants, because this is something out of scope. The status of industry today with respect to energy granular monitoring is, in my opinion, that I would say also in our opinion, there's much to do on that part in order to empower decision making. That's something very strategic that we have to consider in the future. Thank you.
Yeah, which leads on nicely to the next best practice, which is using that data and that quality data to drive decision making and performance analysis. So we want to maximize the insight from data-driven performance analysis, and this is important because we need to accurately measure and verify energy savings, and that's a big barrier that we see as well in the pilot cases that we have, and to successfully deliver energy efficient projects. So what we get from that really is to be able to unlock the value of data to realize this continuous performance approach. And we can, with the tools that we develop, leverage analytics, digital twins, robust assessment methodologies, and all that really relies on that reliable data plane, if you like, to give us these opportunities to do that. So in terms of what we provide as projects is we offer opportunities to do online lifecycle assessment. We make it easier to deploy machine learning and AI models and workflows within existing processes. And we support the integration of digital twins and process modeling, again, to inform better decisions. And we had a focus around transportation efficiency and CO2 reduction across the whole value chain, in fact. So these were the key elements that contributed to definition of this best practice. As we go forward then, another key element is developing this strategic approach for skills requirements. So as I said, a lot of our tools and systems rely on digital technologies, so we needed to address any digital skills gaps that might exist to ensure the adoption of these new technologies and practices. So what we need to do is we need to promote an interdisciplinary approach across manufacturing, technology, education sectors, and we need to create new opportunities to bridge the skills gap that exists within industry at the moment. So this required, firstly, understanding what are the needs for upskilling in an organization, which can be very specific to different sectors. And then how do we support and identify the right training, the courses, and approach to upskill individuals and teams. And lastly, then the assessment of the effectiveness of this training and its impact on the learner is really important to be able to say that we've successfully bridged the gap. So as part of these projects, we developed skills assessment approaches. We've developed kind of tools to automate the matching of particular training courses that might be available free or delivered by the company themselves to the needs of the individual. So it's very personalized for their training needs and upskilling and continuous professional development. And then obviously we developed a set of approaches and techniques for assessing the training that was executed at each of the pilot sites. Another key element is embedding the sustainable production practices into existing business processes. So decisions related to energy, so they're often done kind of sporadically and independent of production processes. So energy is a second thought. And as Andrea mentioned at the beginning, a key factor of the project was to make it a key criteria in any decisions being made in the production facility. So they either occur in silos or the impact is not typically considered across the whole value chain or facility. So it's not always clear how to make those savings as a result. So what we wanted to do is we wanted to leverage existing methodologies for optimization, optimizing energy efficiency. So we used approaches and methodologies that were well defined, standardized, and just embedded them into the process optimization and scheduling. And we automated the assessment as best we could and provide decision support tools then that can be utilized across the different stages in the production process. So these tools then involved demand forecasting, carbon footprint evaluation, life cycle assessment and optimization or control solutions as well that can be deployed on lines, sustainable production planning, maybe to maximize the use of renewable energy, for example, and then correlation of performance improvements from product across the process, so and looking at from start to finish. There's a couple of other best practices that we have that we won't go into detail here today, but this was around business practice for digital transformation. So really getting the buy-in from people in industry is quite challenging. So we needed to ensure that we can have the leadership on site to kind of drive forward these energy efficient approaches and digitalization strategies. And we wanted to make sure that we could build an ecosystem or a collaborative community around embedding these new technologies to support energy efficiency and sustainability more generally. And the other best practice was around, as I mentioned before, applying and promoting the use of standards. So there's there was quite a lot of standards available, but there was a subset that were appropriate for energy efficiency, so around energy auditing, benchmarking, and ISO 50001, which for us plays a big role in terms of the continuous performance management. So that gives a kind of a whirlwind tour of the best practices that we've defined out of the projects. So what we might do is just take a breath from us speaking, and maybe if you could go on to Menti, give a little bit of feedback of who you are and maybe answer a couple of questions about the relevance to these best practices for you. So we might just take a couple of minutes to do that. It's really just for us to kind of capture as well for those that are online, just to understand maybe where you're coming from and what we're doing.
Yeah, different perspectives, different. I mean, the richness in this kind of initiative is to try to capture different point of view, because I mean, energy and energy saving is such a common goal, which is in the end composed of many different ingredients coming from many different perspectives. And the more diversified we are, the more we can try to incorporate and increase.
So that's great. There's a good few ones popping up there. So the first question is just about your background. So the next question is just for us maybe to see if there's any cross-fertilization that can be done based on the participants today. So if you're representing a project, it would be nice to include it there maybe, and we could reach out and share some experience. There's surely someone from E2COMATION here, Mr.
I injected some viruses here and there.
And the last question about yourself would be, what's your main focus of your organization or your department or of your research, if you're a researcher? So if you could just select maybe from the list that's provided. Okay, so a few questions specific then around the best practices. So these are very straightforward in terms of yes, no, and we might get into more, excuse me, more detailed discussion around them afterwards. But just first question is around organizational relevance. So do these best practices that you heard today align with your goals and objectives? So do you see them as being helpful? Great. Second question then is around their application. So based on maybe what you've heard so far, do you feel they, if applied, they could improve energy efficiency or they could support you in your organization?
We managed to convince two people in between.
Okay. And just the final question, do you see challenges to their implementation? So the more yeses, the more opportunity for discussion later, so on this one. Okay. So we'll dig a little bit deeper into each of them after the discussion, but what we might do is jump back into the presentations and give you a little bit more deeper insight into the individual projects and how they relate to the best practices that we develop. So we might start with E2COMATION, if that's okay.
Thank you, Alan. So the idea is not to throw all of you in the depth of E2COMATION because we wouldn't have all the time to do it like that, but just to bring you on one example of what it was developed in the project. As you may remember, I mean, the strategic goals, it's quite common for the two projects. So looking at optimization of energy usage at the various level of a manufacturing process, but also taking a look at the other side of the coin, as I like to say, that is to say the life cycle assessment perspective, because it's not always true that acting on energy saving automatically implies being more sustainable. Maybe somehow disturbing what I'm saying, but we can open a discussion on this. E2COMATION, as I said at the beginning, was to empower decision-making in order to answer to the question, how can I efficiently, energy efficiently, but also sustainably steer production, which is a complex and diversified process. The aim of this picture is to tell you that the problem has several different facets to be considered, and surfing on a trajectory has many implications. In order to tackle this objective, we developed basically 4 different layers. One is related to retrofitting existing plant in order to get out data, because energy is a sparse information, it's not a monitored information, is not available at the granularity that is needed, and interacting with automation system is far from being simple and easily achievable. The second layer for us was to try and to dig into data. The majority of companies either do not have data to look at, or if they have, they don't look at them. Meaning having tools in order to look at trends of data, finding correlations, understanding occurrence of events, and understanding the root cause relationship that are between is something that is very useful when I want to become from reactive to proactive in looking at energy and steering the dynamics of the project from an energy efficient point of view before things happens. On top of this, the other 2 layers that were developed in the project contains tools for factory optimizations and life cycle assessment, dynamic life cycle assessment, which means not evaluating life cycle assessment impact after the production has taken place, but evaluating them while production is running to use this information to steer production. Today, I would like to bring you on to open only the page of in-process factory optimization from an energy-aware point of view. So trying to give an example of what does embedding sustainable production practice means into a company. What I will talk you and show you in a while is what we talk energy-aware optimization. I mentioned it before. The point is that today companies are normally managed prosecuting the throughput of production, considering maximization of production efficiency, and considering energy as a side effect. But today we are all asked to be sustainable. We are all asked to be energy efficient. For us, energy efficiency means in planning and scheduling means considering energy consumption not as a consequence of the production, but as an ingredient. That is to say, how can I continuously modulate the energy consumed in production while production happens, using and exploiting the degrees of freedom in the process, so things can be done, but there are several ways according to which things can be manufactured, respecting production sequences, respecting production constraints, but using the degrees of freedom that the process offers and exploiting energy modulation by taking out values, because all companies are throwing energy on the energy market and they are asked to exploit energy hourly varying price. So the point is, okay, energy cost is varying, my production is pushing, how can I accommodate these 2 aspects? So how can I modulate production, being able to produce better and faster in energy convenient time slot, and avoid the peaks of prices, so avoid the most costly hourly slots in the day. I will show you this example in giving you a bit of a background of the end user that we used in the project and that offered his manufacturing plant. So we are talking about MDF panel manufacturing. We are talking about something which is contained in this room. This table, the door, the laminate flooring, majority of the components, many of the components in this room are from this kind of industry. So it is an energy intensive process. We are talking about process industry. We are talking about a process that starts from the wood logs, enters into a several 100 meters long production lines in which the logs are crunched into small pieces. They are steam conditioned, they are thermally conditioned, they are somehow seasoned to the level of creating a paste. This paste is crunched, and then it's added glue, it's dried, and then we have the downstream process of creating the wood panel as you normally perceived in your daily life. It is a very energy intensive process. We are talking about a process that consumes nearly 200 million kilowatt a year. Out of this, 160 million kilowatts is self-generated. 25 millions are purchased for the net, are sold to the electrical network, and only 2 millions are bought. So you can maybe imagine how a complex process that treats 24/7, a process that includes steam, hot oil, electrical energy. It involves gas turbines, so it generates CO2 emissions, wastewaters. It has high energy consuming equipment. How this very complex and interrelated process and generating elements is something which is far from being simple to be steered. I know it's a bit hard to get familiar with this, but let's just consider which are the questions that the decision maker, so the supervisor of this kind of plant, has to respond. He has objectives and he has preferences. He wants it to increase production rate, but he wants also to lower electrical power consumptions, and these are contrasting elements. He wants to increase the quality of the product, but he wants also to increase the tool life, which decreases, increasing the throughput. He wants to reduce the production discard, but wants also to reduce the steam consumption, which is a high impacting element. All these are contrasting actions that requires experience, that requires sensibility, and that requires knowledge of tons of data that are widespread. We are talking about more or less 4,500 signals varying each and every second. So developing an image of what's going on, and on top of that, developing a tool which is able to perform this optimization, so perform process multi-objective optimization, is a problem to be tackled, because we have several dimensions that needs to be considered. What you are looking at is one example of the tool that we developed that is there to support the decision maker, because remember that our objective is I have many elements to handle, which are in the top right corner of the picture, in the red, in the green area, which deals with the process variable, product quality, ingredients, and I wanted to steer production, getting out the best from quality, but trying also to save energy. And save energy means regulating crunching, regulating steams. But if I regulate the steams, I have to increase other aspects which are energy consuming, and so on and so forth. So the point is, as you may see, they're developing a tool that may compute, using digital twin models of the plant, several possible operating points of the plant. Remember that today plants are normally run by decision maker on one steady state, meaning they do today what they did yesterday and what they will do tomorrow. Offering them several possible equivalent production point, equivalent in the sense that they offer different compromises in between production quality and corresponding energy, is a way for them to steer production towards a more efficient production point. You see in the left, the shape is what we call the Pareto front. That is to say, it's a compromise in between. It is a concurrent optimization of production quality and of energy consumption. On the right, you see the consequence of this. So the effort in production quality and the effort in energy consumption broken out at the level, drill down at the level of every single production point. But this is also meant to be an interactive tool because the user can pick up one point of operation and decide to magnify it, to look at several in the neighboring area to create other production points and to ask the tool to compute a new optimization point to operate the plant. I have spoken till now about product optimization. So out of this tool, you get the set points to give all the single equipment to be energy efficient. The continuously changing in time production set point to be energy efficient. To the point in being energy efficient is that one thing is computing, the other thing is prosecuting the control, which means I've suggested the operator what needs to be done in the next 4 hours, but I have also to deliver them tools that are able to control the plant in order to follow the set point in an energy efficient way, minute by minute, second by second, because the process changes because of exogenous elements. We are talking about wood. Wood changes by humidity, by type, by composition. We are talking about a process that involves energy, when it involves steams, so we have several operating conditions. So delivering tools that gives the operator the possibility to close the loop from a control point of view in an energy efficient way, following the trajectory that he has computed before, this is what we believe is the recipe to be put in place at the various level of production in different contexts. We have also, I will not talk more than this, but we have similar tools and similar concepts developed also for the other use cases, so bringing the same energy wave philosophy in optimization here, which is process industry, in furniture manufacturing, which is discrete industry, so more batch-wise production, and also in other neighboring industries that we have developed and that we have considered in our project. Thank you.
Perfect. Thanks, Andrea. And I'll just give a little bit more insight into one of the use cases in denim. So the focus of this use case is in medical device manufacturing. So just a bit of a profile of the company. So Dupuis Synthesis was a Johnson & Johnson company. So they manufacture medical devices and they're located in Cork in Ireland. And the focus of denim really was looking at the medical implants, specifically knees, the manufacturing of that, using ultra high molecular weighted polyethylene. Don't even know how to pronounce that. But the site also features renewable energy, so wind turbines, PV and CHP, so they're quite effective with their integration of renewable energy. So the focus was on the poly-value stream and auxiliary services that support that, and what they really need to do is digitize the production process to be able to monitor energy at a more fine-grained level, improve efficiency over time, and then implement any decision support systems to bring their costs down. And they also wanted to maximize the use of renewable energy across that particular value stream. So we had a number of different targets, and the three kind of areas that we looked at was around enhancing digitalization, improving energy efficiency, cost and waste reduction. So we had quite ambitious targets, I would say, to achieve in this particular pilot. So then to use the best practices in this context, so the first step obviously is setting the strategic objectives for digitalization to support these targets. And to do that, we defined what we call the energy efficiency pathway. And we actually devised this pathway in collaboration with the other sister projects that fund under the same call. And this combined a digital maturity assessment, which provides a mechanism to plan and track the progression of each of the pilots along the digitalization journey in order to support energy efficiency management in manufacturing systems and processes. So then there's a direct correlation, as you see down the bottom, the DENIM platform implementation. The different tools and services we develop maps directly to each of these milestones. So the pathway has 5 milestones, and a company can either start at 1 or it could be at 3, and you're just finding different levels in that milestone. And it's kind of going from not really doing any energy performance management right up to online continuous energy management over time. So there's a couple of elements to this as well in terms of enabling technology and different focus of the dimensions and levels. And we just wanted to support or provide a mechanism for a company to track their progress across this pathway. So we, in collaboration with EFRA, so this pathway is on the EFRA Innovation Portal, and this is beneficial because we can now map our results of a project directly to elements of this pathway. And then for each of our case studies, we're able to kind of say what the targets for the pilots are, what's the impact of digital maturity and the use of the DENIM solution is over time, and then be able to kind of track at each implementation step lessons learned at each of these milestones and dimensions that we have in it. So similar, if you have a project on the EFRA portal that you feel could contribute to any of these milestones or any of these elements of the pathway, you can link your project results to this as well. And those that look for it can find them there. So in the context of the Dupree pilot, we looked at the energy efficiency pathway dimensions, so energy monitoring, performance analysis, impact assessment, sustainable production practices, and the use of standards and best practice. So the Dupree site itself was relatively mature from a digital perspective, so they're already deriving insights from data that they collect from the production floor to try to help improve performance, but they lack integration across the different business units, the different digital tools, the different services, and they needed help to achieve that through the use of DENIM. So through the DENIM platform development, we created a number of services and I suppose opportunities for them to increase the digital maturity, and that was really the focus within this company. In terms of the progress, I would say, so as I said, they were fairly mature to start off with, but we increased their maturity index by almost 10%. And that was really around new services that we were able to provide users in the factory floor or planners, just to increase visibility and have access to analytics tools to allow them to make better decisions. In terms of the sustainability maturity, so we improved that by a further 10%, and that was achieved through integration of the decision support tools, such as sustainable production planning, integration of renewable energy into their particular process. And then this allowed Dupree to move from just deriving insights from reports that they generate from the data and streamline coordination across automation teams, business functions, and optimize and sustain energy efficiency in the poly value stream over a long period of time. So with regards to the strategies for reliable data management, so as Andrea mentioned, this was a really critical step in the project. So we needed to have a platform that could integrate with legacy systems, as well as adding new metering and new functionality to collect and aggregate certain data sets that were used for decision making. So if we look from the top down, so this is an overview of the platform. So we have a core data platform that basically aggregates data together and make it accessible to different services, tools, and third parties with a set of APIs and connectors associated with that. We provided data connectors for the different systems that existed within the pilot. So, for example, they have systems for production planning, they have systems for monitoring machine data, and then they have building management systems around auxiliary services such as air handling units, etc. We also developed a number of data quality services to make sure that the data that's coming out is of good quality and usable for our modeling tools. We created a number of user interfaces to allow them easily interpret the data and inform their decision making. So we created a 3D visualization using digital twins to monitor real-time energy on specific services, and we also have a context-driven visualization which was really focused on kind of dashboard views on energy flows and understanding where that came from. And then we developed a number of services and modules across that to identify opportunities to reduce effort in generating reports, to monitor consumption and the use of renewable energy, fault detection and diagnosis across different assets, such as the air handling units, to make sure they're running optimally, and then sustainable production planning. So again, offering different options and opportunities for the production to really optimize energy use across it. So the value of this kind of modular approach is that we're able to customize it then for the needs of the different pilot sites. So as I said, they were quite diverse in terms of what they already had existing and what they needed. So we're able to then cherry pick which services, which tools, what complexity of platform is needed to meet their particular needs. And then to look at the maximizing the insights from the data-driven performance analysis. So we take that platform, we can deploy it across all the sites, and then we translated that into a number of scenarios to really showcase the opportunity for improvement. So we have 4 particular scenarios in this context. So we monitor the energy flows, and we're able to reduce the complexity of collecting data by 30 to 40%. We deployed 2 new digital services, and 5 assets had services to automatically generate key performance indicators and visualize that for the energy manager on the site. Then we looked at sustainable production planning. So this was again optimizing the use of renewable energy, and we were able to achieve 10% savings and integrating simulation into that. So forecasting the renewable energy, and for the poly value stream scheduling, there was potential of saving 18% of energy by using these renewable sources. Fault detection and diagnosis was another big part in this project, because they have quite a large number of air handling units on this particular process line. So we increased the digitalization of these and the monitoring of the production assets. So 25% of production assets were increased monitoring, and then 50% of the support assets had fault detection and diagnosis services running on them. And these were automated, so these were generating alerts and informing maintenance requirements and root cause analysis to ensure that they're operating correctly and not using too much energy. And then we deployed data quality services as well, because that was a big issue for them across lots of different systems that they had, integrating quality checks to make sure the data was consistent and it could be relied on to make the decisions that they were looking at. So at the pilot, specific elements that was achieved, I guess, around digitalization, energy efficiency and waste reduction. So we added new sensors for the significant energy users to really target the focus where we could save the most energy. We deployed the platform, and we deployed the fault detection diagnosis services as well. We created a number of energy models, and we integrated the renewable energy and control systems around that for optimization. And then the visibility of energy flows really gave them an opportunity to target where they could invest initiatives to address sustainability and energy efficiency. A big issue on that site was a lot of the machines were running in idle mode for a long period of time. So we were able to identify that with the DENIM services and reduce the cost associated with that, and reduce the scrap rate by providing greater visibility of what was happening at each process step and the aggregation of data. So then another key challenge there was the turnover of staff and the retention of knowledge. So you would upskill them on the use of these digital tools, but if they move to another business unit or they left the company, all this knowledge was lost. So we had to develop kind of a strategic approach then to maintain that knowledge, and the upskilling element of it was quite important as another best practice outcome in this pilot. Just in terms of numbers, so we increased the production and assets monitoring by 95%, and there was 20% savings based on the idle energy reduction achieved, and the potential for 18% savings with the integration of renewable energy. And there was 75% of the assets were now monitored with automated fault detection and diagnosis. So that allows us to embed the sustainability practices in a continuous basis. So we're just looking to finalise these pilots now with further automation and use of those tools and validation of that. So this is just an example of a particular element, so monitoring the significant energy users on the site. So it was a very manual process. So they would export the data from OSPI system, import it into Excel, set manual baselines, manual control limits. They would calculate the performance indicators, generate graphs and the report, and this would take significant amount of time, number of days to do that. So with the DENIM solution, we automated a lot of this process. So we took the data directly from OSIPI into our data platform, which was has security on it, so only those that can access that data get access to it. And then we automated the aggregation of that data into energy performance indicators and provide a visualization for that. So just to give a little bit of more of an overview, I'll just run this quick 3-minute video just to show you the kind of pattern that we used across all pilots.
In this video, we will see an example of the integrated DENIM digital intelligence platform and its use for asset management. The first step of the process is to specify the assets, meters, and sensors that are deployed at the manufacturing site aligned with the DENIM semantic model. These crucial initial steps lay the groundwork for a seamless integration with existing building management systems and sensors. The creation of a semantic model is undertaken, ensuring a standardized understanding of data across the DENIM ecosystem. With the site and semantic model in place, DENIM initiates integration using the OSIPI connector. This connector serves as the linchpin for extracting data from the BMS and installed sensors within the facility. The synergy between data configuration, semantic model, and OSIPI integration ensures a cohesive and harmonized flow of information. Post-integration, the DENIM solution employs Kafka streams to propel data towards its core data platform. This dynamic streaming approach guarantees a continuous, real-time flow of data, preserving its accuracy and integrity throughout the processing journey within the DENIM ecosystem. Fault diagnostics and detection models have been developed to support root cause analysis of production assets are developed and deployed within the DENIM platform. The comprehensive visualization is demonstrated through the development of a 3D graphical user interface. This tool enhances the interpretability of results, providing stakeholders with a multifaceted, immersive insight into asset performance. This robust prototype isn't confined to a single site. It serves as a blueprint replicated across diverse pilot sites. Different models and approaches are employed to optimize parameters, ensuring the adaptability of DENIM to the unique intricacies of each site-specific process. For more information on the DENIM project, please visit our website, and thank you for watching.
thought. So there's new faces down the back that I don't know, so I don't know if you have any insight of what you heard today, maybe. No? Okay. Do you want to say it?
What was the curiosity that drove you here? You, I mean all of you, not only the 3 ladies that were targeted. What were you expecting or willing to find?
I have a question for the commission. So, we have seen that already speak also.
Yeah,
It's just
for the online guys, yes, and ladies.
So, okay. So we have seen that these 2 projects works with the digitalization of processes, and the main bottleneck for improve the digitalization inside the factories or machine is the availability of data. So my question is, what is your opinion about improve the data, the quality of data, and so also the installation of new meters, new sensor inside the factory without European contribution or without any kind of solution that can help the owners, the manager to collect data and also help the digitalization, because without data it's a huge problem.
That's practically impossible. That's a huge question for sure. The point, let me start from the last part of your question. When you have to gather data out of production lines and out of the machines, there are 2 main aspects that you have to convince people managing the factory about. First of all, how useful are these data and how different they are from the perception they have of the process they are running. Before I was just saying that in the majority of cases, production tomorrow will be done the same way is being done today and was done yesterday. Because the speed of the process, and I'm not talking about speed itself, but the willingness to continuously push production does not give people the possibility to look at what they are managing. So there is plenty of things to discover with not that much big investment. Let me come to your specific question. In the majority of cases, you cannot open existing automation, meaning that to get out data, you are basically running machines you do not own. You bought from third party, which do not have, which do have legacy systems that are not open or cannot be open, or if they are open, it's because you have to pay for that. You have to find people opening that, and that's a nightmare. But I mean, there are solutions on the market. It's not only a matter of the power meter itself, it's also a matter of what's coming with the power meter. So how to lightweight, soft PLC based system to gather data, to collect data, to sample data, and to send them to the first floor from the shop floor. And the investment at machine level with existing complementing solutions, which means you keep your automation, I mount something outside that can help you getting out energy data and or pressure data and or production data. The investment is not that big. The problem I see more is convincing people about the importance of drilling down the data at the level of minutes, I'm not talking about seconds, which would be a dream target. Majority of, when we talk about companies that have energy monitoring systems, they normally have, energy measuring systems, they normally have either on some portion of the plant and not on all the plant, and they measure the full portion of the plant. And which means maybe in that portion you have 6 machines, 7 machines, 20 machines, you get the sum of consumption. And you get it sampled each and every quarter of an hour or each and every multiple of minutes. But when you have a fast-paced product, what can you get out from this kind of information? Basically nothing. Or basically you get the main dynamics, but you don't get what you get out from the process. So here there is a gap. Here there is a possibility to shift something. So in my opinion, convincing people about the importance of investing is the major effort. Because in terms of investment itself, I'm not saying it's cheap. What I'm saying is not a big capital investment to get out things, if you want to scavenge value out of your process. And it applies to several industries, what I'm saying.
I would say from the denim perspective, putting metering was easy, right? But if you wanted any more process parameters or anything like that, that had to come from the machine itself. It was almost impossible. So then you have to rely on operators maybe to collect that data or the mechanisms to collect it. But it was very challenging to convince those that are spending the money that, if you actually do invest in this, we'll show it. So we did that through, for example, for the fault detection, did it on one unit. And if you show the potential on the one unit, then, okay, they're more inclined to roll it out to the rest of it. But it's, with the best practices, tying it back to particular examples that show the value of it was the only way really to convince them.
Thanks, Alan. So yeah, I'd bounce back on that and say, from my understanding, it's that people like workers, managers, and also organizations are resistant to change, are fighting the fact of changing, and maybe something that we could address otherwise in the best practices is the notion of incentive, which incentives we give to those who are in charge, who decide to invest. How do we convince them that they have to, that they should be better off if they did? So maybe the question is not only at the technological level, at the implementation level, but also before that, in the thought process leading to making the change in the approach and the willingness to extract data and to look into it. So it's not very much of a question, maybe more a comment, but...
No, but elaborating on this, what normally happens is that, first of all, it's like cooking. The pot is ongoing, it's boiling. Nobody wants to open the pot because you have to deliver the food. But once you open the pot, you discover that what's boiling in could be boiled differently, could be more tasty, something like that. So the point in the various use cases that we face is that it is true that people managing factory have to shift a bit of their energy, mental energy, in understanding if and which is the energy problem. But once you convince them, and the only way in our experience to convince them is to provide them with meaningful and aligned insight, live insight on what's going on, so they can look at that and say, oh, so this is, let me say, the double click on the block, you are magnifying, so I see the dynamics in that, that's interesting. Now I can find the explanation for that problem, for that specific occurrence and things like that. So if you succeed in engaging them at this level, then I don't want to say it's easy, but at least they are on board. But again, I was get back to what I was saying before. When you are pushing 24/7 over the production, and your goal is to get out the panel or the furniture or the bottle or the whatever, I mean, that's, there are things flowing in parallel you don't see. And the point is that either the owner of the company decide that energy is today a problem. If it was not a problem till yesterday, they throw energy problem on the table and tells the manager, now you have to solve also this. And here is the problem starts, because it gets back to getting reliable data, getting aligned data, getting meaningful data, getting explained in the logic and in the knowledge domain of people you are talking to. And this pretty much recollects a number of things that Alan was mentioning in his presentation.
So in terms of how we might present the best practices, so do you feel, would it make more sense to present it in terms of its application in a use case, or energy savings or cost reduction as incentives? You know what I mean, in terms of encouraging them to apply those techniques?
More of the second case. More of the second case. And maybe also showing that there was an engagement process at the very beginning with the pilot sites, which were incentivized into dealing with those projects and making efforts which they wouldn't have otherwise. So it's at both ends of the process. It's already a best practice that you were able to engage with those people, as you said, showing that they had some reasons to do it, and then ultimately showing that they earned something from doing it.
Is there any thoughts in the room about the value of these? So if maybe you're working with industry already in other sectors, and if you brought them these best practices, what do you think their reaction would be? Would they kind of say, okay, good, but how do we implement it, or what do you think? And maybe to kind of inform maybe how we better present the best practices in that way. I know there's some fellas in the room that work with industry quite a bit, so maybe some thoughts on that, Marco.
Yeah, for sure. Some best practice could be really valuable for in industry. Let's say we saw in another project. For sure, it could be a starting point. The question about how we can implement this one, I think, could be happen, but we already explained a little bit, and I think the detail that we reach with this best practice can really help the transition between, okay, now what's we have to do in, okay, we have to do this step, this step, this step, especially from the data gathering that we discussed. So, no, I think for a couple of them are really a key point for the next project or the next project, and because also if the topic is changing a lot, there is really connection with this type of best practice. So I think we can say that the dissemination of this activity is really parallel and take different sector, not just industrial, but also related with the totally different topic, not energy consumption, but maybe the manager of the process itself. I saw another project that they focus a lot in the process and to optimize or change it, definitely all the process, but the main problem should be the same. So I think they have a really good value for dissemination activity.
Just maybe, Andrea, from your side, what do you think was the biggest challenge you faced in either of the pilots? You know, or were there very different challenges in each one of them, or was it a common difficulty? If we even look beyond the data gathering issue.
going beyond the data gathering is, I mean, when I was saying before that in order to be energy saving, you have to be proactive. Proactive to me meant not to wait for the occurrence of something to discover that you lost an opportunity, but to predict or to early detect a trend in some variables or a trend in the process that it's likely to cause something that may harm energy efficiency or sustainability. The point with this early detection is that there is a kind of, how to say, big misunderstanding in between the process manager and the data analyst or the data analysis tool. It's because both of them implicitly rely on the knowledge the other guy or lady will throw on the table. So the process manager normally wants from the data analysis the magic. Tell me what's gonna happen, when and why. I didn't know, but you saved my life. I'm trying to be quite harsh in my expression, but just to deliver you the mood. And the data analyst is the data analysis is the other way around. If you tell me what I have to search, I will search it for you. Mechanism to capture this kind of things, which may use semantics also to some extent, generating rules for stream analytics would be the next step to better leverage the data before to empower decision making and so on and so forth. Because I mean, energy is consumed while it's doing, while things are done. So either you discover what's next before it's coming and you steer before, or you're done. So mechanism to integrate the
across business functions and
cross business, but also the shop floor itself. Because I mean, I was talking about this plant, but also for other plants. There are so different production steps that are silos, as you said, that normally works on a steady state that was the traditional steady state. I do like this because before me, there's you, and you do the things that way, which triggers me, and so on and so forth. So things are crystallized, and when you ask for flexibility, who's doing the first move to be flexible? Me? Upstream guys? Downstream lady? None of them. So getting out from this deadlock.
Yeah, getting them to talk to each other and kind of share their needs as well is an element of it.
Showing each other the degrees of freedom, the flexibility that they can have, because they have. I mean, there was, at the very beginning of one experience that they had in the project, the very first answer that they provide to a company was, but did you realize that if you keep exactly your production the way it is, but you shift it by 1 hour, you save 5% of energy. Not changing anything, simply starting earlier. Doing exactly the same things you do, not changing anything. So there are opportunities there, but if there is nobody raising the head to look at them and to realize that, okay, I can do like this, you can do like that, let's combine. So the energy where part I was mentioning is not a magician, it is a combination of different things, offering the degrees of freedom and combining according to criteria, digital tools, and so on and so forth. But there is knowledge capturing, modeling, optimization, several people around the table. The guy from the generation system has one mindset. The guy from production that uses the energy from the cogeneration has another mindset. Who's driving whom?
We saw practically the same, just shifting a little bit the production scheduling without taking care about the deadline. So the deadline was the next day. So without lose constraint and everything, we can save like 80%. 8%, sorry, and also just to leave the machine in idle time for 4 hours. Say no, okay, just turn off the machine and turn on. We can save like 5%. So
yeah, and
the level of flexibility, it's really.
And if you tell these kind of things, people look at you and they say, oh, okay, you are lying to me.
Yeah.
Is there anybody who never realized that there is this kind of opportunity? But this is, let me say, this 5% or 8% is the baseline.
Yeah.
But on top of that, there is something which is not a baseline, but which is a big opportunity. I mean, the company I was talking before consumes nearly 200 million kilowatt a year. These are not nuts. So a 5%, a 1% of this, a 0.5% of this, it's a huge, and can we say that there is no room for this improvement? It's not credible at all. Then another element is that there may be a compromise that somebody has to reach, because capital-intensive industry has different investments behind, has different attitude with respect to discrete manufacturing, which has lower investment, so it has maybe less flexibility, but still there is room in both areas to get out something. Partializing auxiliary systems, just to say something that you turn on 8 o'clock Monday morning, turn off 5 o'clock Friday evening, up and running. Do you use it? Compressor systems, oil, things like that. Do you squeeze out the best of these systems? I can't believe it.
So I suppose the message is that there are opportunities there, and that the tools that both projects developed, I suppose, bring them to the fore and give people opportunity to really identify what these opportunities are and make those savings and have a real impact. So we've come to the end of the session now, so I would just ask one last question on the Menti, if you don't mind, just maybe prioritizing, or which priority you think, which best practices would you prioritize from your perspective? If we could just get that feedback, that would be great. I think for us, the next stage is to kind of package these best practices into an accessible repository that could be disseminated across different industries and shared among partners. So if you have any feedback, just send it to either myself or Andrea or anyone in the project, and go to our website where you can find out more information. The slides will be available as well anyway for any participants, and there's access to download the best practices is in the slides also. So thanks very much for your attendance and attention, and we'll close the session.
Thank you.